to the Math Theory Basics. The goal of this video are to define basic set vocabulary and set concepts. A set is a collection of distinct objects, and the objects can be called elements or members of the set. A set does not list an element more than one, since an element is a member or it's not a member. We've actually already studied sets when we define the set of real numbers. Remember, all real numbers are made of either rational or irrational numbers. And then we can break those sets of numbers into more specific sets of numbers as well. And capital letters are normally used to identify a set. Now, there are sets that have repeated elements, and these are called multisets. And this will not be addressed in this video.
So, we're now going to focus on different ways on identifying a set. The first way is a written description. We can state that set A is the set of calendar months beginning with the letter J. We can also identify set A using the list or roster method, where we list the actual members of the set. So set A is equal to January, June, and July. And we can also use something called the set builder notation. Set A is the set of all elements X, such that X is a calendar month beginning list with the letter J. All these represent the same set.
So describe the set of these three colors, and the description could be B is the set of the primary colors, or using this roster method to consider, B is called the set where the colors would be red, blue, and yellow, or using this set builder notation. Set B would be called the set of X and X is the primary colors.
This is also a special set called the empty set or null set. This is a set having no elements at all. The notation to be used in this set would be either these two notations. For example of this is B is the set of 5-sided squares, so that 5-sided squares would be empty set or null set as identified as here. We can also use these two symbols here to indicate if an element is a member of given set. So for example, is set C is the set of even numbers greater than 2 and less than 12. Let's first identify this set using the roster method. So we can't include 2 because 2 is not greater than 2. So we have 4, 6, 8, 10. Also, we don't include 12 because 12 is not less than 12. So we consider 4 is an element of set C, 6 is element of set C, 8 is the element of set C, so as 10. We can also say that 2 is not element of set C, and 12 is not element of set C, and of course, many others.
Now, let's talk about cardinality. The cardinality or cardinal number of a set is the number of elements in a set. We only use these two notations to represent the cardinality of a set. A subset notation does not repeat elements, which is the calendar months of each set, to identify the cardinality of a set. The cardinality of a set A, which is 1, 2, 3, 4, 5, and 6, because there are 6 elements in a set. The cardinality of set B would be 1, 2, 3, 4, 5, and 6 as well. And the cardinality of set C would be 3. Now, two sets are equivalent if they contain the same number of elements. If two sets are equivalent, they can be placed in one-to-one correspondence. If two sets are equivalent, we write their equivalent using this notation here. Looking at these two sets here, we can say that set A is equivalent to set B because they have the same cardinality or the same number of elements. Now, let's be careful about this word equivalent. Often the master use when things are equal. Also, these sets are not equal, but they have the same number of elements. Of this idea, of this one-to-one correspondence, just means for every one elements in set A, we can match in set B, so we can match 1 was 2, 2 was 3, 3 was 8, 5 was 11, 8 was 12, and 9 was 13. It was written the 1 and 1 correspondence.
The two sets are equal if they contain the exact same elements that may or may not be in the same order. So, looking at these three sets here, notice that set A and set C have the same cardinality, meaning they have the same number of elements and they also have the exact same elements. Set A and set C contains the letter A. Set A and set C contains letter B. Set A and set C contain letter C. The set A and set C contains letter D. So, they have the exact same elements, therefore the two sets are equal. The set A is equal to set C. The last thing I want to mention is that all of the sets we have seen in this video have been finite set, meaning they have a certain number of elements or terms. The cardinality of the empty set is 0 because the empty set has 0 elements, but the cardinality of an infinite set we say is uncountable. However, we can use something called transfinite cardinal numbers to describe the size of an infinite set. But right now, we're just going to identify the cardinality of an infinite set as uncountable.